Hello YouTube, this is Dazzathecameraman. Today is Friday, July 21st, 2017, and this is an impromptu interactive hangout. Just thought I'd give this a try. I'm not sure how many people will have along since I gave such short notice. I did post this on my Facebook feed, but we'll see what happens. I see we've got a few people waiting there and a few people participating in the chat already, so welcome along. Thank you for joining me. And I just thought it would be good for once just to concentrate on the chat and try and be a little bit interactive and discuss questions and comments that are in the chat, because often in the Hangouts, of course, we're very much focused on what we're discussing, such as the last Hangout that we did a few hours ago, looking at supposedly 5 brown dwarfs next to the Sun, according to Scott from Nibiru Planet X, The Awakening, and his so-called physicist, Dr. Claudia Albers. But I'm happy to open this up to all sorts of other questions, including the huge chocolate teapot, which is incoming, of course, which has just been mentioned in the chat. Now, of course, if you don't know what that's all about, I did do a video back in 2014 called HCT 2014 Heading This Way or something like that, and re-uploaded it recently in light of the ridiculous things that I've been seeing online. And that was my video proving that there was a huge chocolate teapot in orbit around the Sun and actually heading this way. And of course I provided photos, leaked photos of course, you know, very classified leaked photos of the huge chocolate teapot and all the rest of it, and even imported it into Starry Night to just give it even more credibility. So, you know, we can look at all sorts of things in videos and claim that there are things heading this way, but, you know, I can even fake a huge chocolate teapot that's heading this way. Question, did you feel the earthquake about 2 days ago? We felt it big time here and Darwin. It's from John. No, I haven't felt any earthquakes for a little while. I think possibly the last one I felt might have been the big Kaikoura earthquake, or possibly some smaller earthquakes since then off the east coast of the North Island of New Zealand when I've been down that way, down Whakatane way. And this is an interesting thing, is that New Zealand is a very active fault line, and earthquakes here in New Zealand are very much part of life, just as they are in areas such as Japan and other areas around the Pacific Rim of Fire, as it's known. We're on a very active fault line, and earthquakes and volcanic activity is the natural result of that activity. People sometimes act as if earthquakes are not natural somehow, but of course earthquakes and volcanic activity have been shaping this earth ever since Adam was a lad. It's nothing unusual. Sometimes there are more earthquakes, sometimes there are less. That is the nature of random events such as earthquakes. What else can we cover? Sun paths. Okay, I'm Rick, asks about sun paths. Maybe you're asking about where the sun rises and sets, and maybe claims people say that the sun is rising or setting in the wrong place along the horizon. And this is a claim that we've been seeing for years from people who seem to think that the sun rises due east and sets due west every day of the year, which of course it doesn't. There are only 2 times of the year that the sun rises due east and sets due west, and that is during the equinox, which is in March and September. Now, between March and September, or September and March, depending on which side of the year we're talking about, of course, the sun actually drifts along the horizon. This is the same product that causes the seasons due to the Earth's 23.4 degree tilt on its axis. In March, around about March 21st, 22nd, and September 21st, 22nd, the Earth is side on to the sun in its tilt. So the northern hemisphere and the southern hemisphere are getting just as much sunlight. It's called equinox, meaning equal night. Equinox, equal night. and that is why the sun is due east and due west at the equinox. At the solstice, of course, in March and June, you've got the sun is at its furthest point along the horizon, depending whether you're in the northern hemisphere or the southern hemisphere, you're in winter or summer. But people seem to think that when they see that the sun is way too far north from what they think it should be, they think that the Earth has shifted on its axis, but they seem to forget that pole star called Polaris, which is visible to everybody in the northern hemisphere. And if you do a star trail video, you can see that Polaris is right where it should be. Now, Polaris is not exactly on north celestial pole, as some people think. It's actually about 2/3 of 1 degree from the north celestial pole, which is why when you do a Star Trails time lapse, you see that Polaris actually scribes a little circle around the actual celestial pole. So, but Polaris is still exactly right where it should be, 2/3 of 1 degree from the north celestial pole. The sun is rising and setting exactly where it should be. If the sun was in the wrong place, then Polaris would be in the wrong place as well. It's as simple as that. What else have we got in the chat? Yes, Scott is a con man. There's no disagreement on that. Flogging off white papers showing spots on image sensors and claiming that they're brown dwarfs next to the sun. Yes, he's definitely a con man. We've seen his hoaxes time and time again, right back from even before I first got involved debunking his videos back in October of 2016. Some of you will remember that he claimed that there was an object filmed in one of the stereo spacecraft images, which he claimed was planet Enoch crossing over in front of the sun. And of course it was the moon, and this was not long after the stereo spacecraft had been launched, and the moon crossed over in its field of view as the spacecraft was heading away from the Earth on its way into orbit around the sun. Now, Astronomy Live has done some excellent work proving that it was in fact the sun. So I'd recommend going over to Astronomy Live's channel, checking out those videos about the object in the stereo. I can't remember if it was stereo ahead or stereo behind. It's one or the other. Now, just going back to a point talking about the sun and where it sets along the horizon, because we've got some flat Earth people pro and against in the chat. Now, it's interesting talking about where the sun sets, because in the summertime, the sun here in New Zealand sets south, or it rises south of east and it sets south of west, which should be impossible on a flat Earth. Because if you look at the map, including any of the flat Earth maps, and I've been told off in the past from the flat earthers saying there is no official flat Earth map, because, you know, I pointed out a very popular flat Earth map that a lot of the flat earthers seem to use even in their own avatars and so on. And I referred to it as the official flat Earth map. Now, a lot of them came back and said that, you know, I was being dishonest, they said, because there is no official flat Earth map, because they say we can't really know what the map really looks like because nobody ever knows, because all this sort of information is hidden from us and all the rest of this nonsense, as if nobody can ever get in an aeroplane and take photos and map things out for themselves. But in any case, my point is that the sun's path above New Zealand, it doesn't matter whether we're talking midsummer or midwinter, equinox, solstice, the path of the sun is always north of New Zealand. But here we have a problem, because in the summertime, the sun rises south of east and sets south of west, which seems to be a contradiction. But this will in fact work when the Earth is a globe. It cannot work on a flat Earth. I mean, simple geometry proves that it cannot work on a flat Earth, because you cannot have something that's north of New Zealand, which is south of New Zealand at the same time. but that does actually work on a globe Earth because of the geometry of the Earth tilted on its axis at 23.4 degrees. Now, I'm Rick asks, and my screen's just gone to sleep. Here we go. Have a serious request. Could you do something that would show the sun's speed at solar noon as it passes over if it is only 3,000 miles high? Well, actually, Mick West from Debunking has actually already produced a simulator that does exactly that. It shows, I can't remember if it actually shows the speed as in miles per hour, but it does show a simulation of what would happen to the angular size of the sun as it gets closer and further away. It also shows the angle and a bunch of other data. As everybody knows, when something is close to you, it looks a lot bigger than when the same object is further away from you. I mean, even a child knows that an object up close looks bigger than the same object further away. And flat earthers love to use that magical word perspective, but they don't seem to understand how it actually works. So check that out with Debunking. Send me a private message. I'm Rick, and I will flick you the link to that simulator if that's any help. Also, you could check out my playlists for flat earth debunking videos, because you'll see that I've also done a series of videos looking at the angular size of the sun and how it does not change throughout the day. Now, some of these flat earthers claim that it does, and they show videos of sunrise or sunset where the sun appears to be changing in size. But of course, they are not filtering out the glare of the sun, and they're not using a sun filter. But when you zoom in on the sun and you use a suitable sun filter to remove all of the glare so that all that you are seeing is the disk of the sun, then you see that the disk of the sun remains exactly the same size as it crosses the sky from sunrise to solar noon to sunset. It remains exactly the same size. Now, when I say the disk of the sun, I'm not suggesting, of course, that the sun is a flat disk. I'm talking about the apparent circle of the sun as we see it in a two-dimensional image. Now, are there any other questions in the chat? We've got a few more people joining in. That's good to see. So if you've got any questions, I'd be happy to try and answer them just off the cuff if I can. Now, it's interesting here, we talk about the weather. I might just touch on this. We're having some fairly extreme weather here in New Zealand at the moment. It's been heavy rains and flooding. And this is something that I certainly do not deny, is that the weather is changing. And, you know, we're looking at climate change. We can see that the CO2 levels are rising all the time. We're seeing increased temperatures year on year, month on month. I'm talking about the average global temperatures, not necessarily just local temperatures. These increased temperatures lead to increased evaporation. As we all know, heat causes evaporation, and evaporation is basically water turning into vapor and ending up in the atmosphere, evaporating away. And we know that that vapor that ends up in the air condenses in cooler weather and comes back down as rain, and that's the whole cycle that we have with the weather, with the water evaporating off the earth, ending up in the atmosphere and falling back down as precipitation or rain. So as the climate heats up, we're seeing more rainfall, and we're seeing more extreme weather events. We're seeing more flooding. We're seeing more landslips and extreme events such as that. This has nothing to do at all with any mythological, invisible brown dwarf supposedly passing through our solar system. It has everything to do with climate change. And I think that this is something that we really do have to get very real about, as people have been warning. Of course, there's not a lot that we can individually do to change things immediately, but individually we all sort of add to the problem by the choices that we make, I guess. And so in some small part, I guess we can try and do what we can to try and limit our effects on the climate, although I know individually it's very hard to make a difference. But the reality is that we are polluting the planet. We are affecting the climate. I saw recently that they're predicting that before too long there will be more tonnage of plastic in the ocean than there will be tonnage of fish, which is quite mind-boggling and very frightening. So yes, weather events are very real. What about earthquakes? Well, as I touched on at the start, earthquakes happen all the time. Volcanic eruptions happen all of the time. Sometimes there are more, sometimes there are less. That is the nature of random events. I'm just looking at the chat to see what else I can comment on there. I'm Rick, Flat Earth Math. In reply to Flat Earth Math, the size change has been done to death. They don't get it, but the speed it would pass might be easier to understand. Okay, so I guess I get what you're saying there, I'm Rick. You're talking about when an object is much closer to you, it seems to move much faster. When an object is further away from you, it seems to move much slower. So when the sun, or the moon for that matter, is passing right overhead, it should seem to whiz across the sky really quickly while it's close, but it doesn't. In fact, its speed across the sky remains at 15 degrees per hour, because we've, take a circle that's 360 degrees, as every circle is, and we know that the Earth takes approximately 24 hours to make one full rotation. So we divide 360 degrees by 24, we get 15 degrees per hour. Now when we see the sun crossing the sky, it's not because the sun is actually crossing the sky, it's because the Earth is rotating at 15 degrees per hour. And what we see as a result, the illusion that the sun is actually crossing the sky. But the sun does cross the sky at 15 degrees per hour. It doesn't get faster, it doesn't get slower, 15 degrees per hour. And if the sun was a lot closer, we would expect to see the sun whizzing across the sky when it was at its closest point to us, but we don't see that at all. And fair enough, Flat Earth Math points out that the angular speed of the sun is only 15 degrees per hour on the equinox. All other times it's slower. And yes, indeed, that would be right, because the sun is arcing across the sky. And the Earth is still rotating at 15 degrees per hour, but the point would be that the sun would be whizzing across over the top of us when it was at its closest point. So yes, you do have to take into account things such as the tilt of the Earth, where we are with the seasons, that sort of thing. Now, with Nibiru Planet X, of course, we keep hearing all the doom and gloom and claims that there's brown dwarfs next to the sun and all the rest of it. Well, we've got an interesting event happening this time next month, and that is the total solar eclipse, which is going to be visible across the United States. It's going to be cutting a path right through the middle of the United States, so it's going to be visible for a lot of people. If you have the opportunity to go to the central path of the solar eclipse, it will be a once-in-a-lifetime opportunity for you. I've never seen a full total eclipse. We had a solar eclipse visible here from my location in New Zealand back in, I think it was 2012, if I remember correctly. It was, I think, about 87% total, if I remember correctly, but it was a total eclipse as seen from Northern Australia, and we actually hooked in our local observatory. We hooked in with SLU and provided a feed of our view of the eclipse from here in New Zealand. But This total solar eclipse, which is happening on the 21st of August, provides a couple of very unique opportunities, and that is to test what is happening with the Earth and the Sun and the planets and the Moon. The Moon as well, of course, being the solar eclipse, it is the Moon passing in front of the Sun. If we had a couple of brown dwarfs within our solar system and our central solar system within the inner planets and near to the Sun, of course, that would be perturbing the orbits of the planets, and that would be affecting everything. It would be affecting the position of the planets in their orbits. So what effect is this going to have on the solar eclipse for 21st of August next month? Well, my prediction is that it's not going to have any effect on the solar eclipse, of course, because there are no brown dwarfs within our solar system. There is no Nibiru Planet X within our solar system, and therefore it's not going to have any effect on the total solar eclipse. The total solar eclipse will start exactly as predicted, it will end exactly as predicted, and it will follow the path exactly as predicted. And remember that these predictions were made years ago, because they can be made years ago, because that's how accurate and reliable the solar system is as far as making predictions for solar and lunar eclipses and so forth. Now, Heidi Ho asks, Dazza, do you have that program where you're able to show, let's say, small 5 brown dwarfs, what would happen? Well, I've only used a very basic gravity simulator, which I could pull up. I've shown that on another Hangout. There are much better ones that I've never used myself, so I'm not familiar with. But we could just pull it up for a bit of fun right now. I'll present that on my other laptop. Let me just pull it up first before I do that. And we'll have a bit of a play with that. Just bear with me while I pull it up in the other laptop. And if anyone's got any other questions that they want to ask in chat, pop them in there and I'll try and take a look. Okay, so I found the simulator. I'm just going to pull that up. Present to everyone so you can see my screen. Make sure that's in the live window. Yeah. Oh, there it is. Okay, there is a bit of a delay between the live Hangout and the public feed. Okay, so here is this gravity simulator, and we'll start with a huge object right in the middle of the screen to represent our sun. So that red dot represents our sun, and I'm going to use a medium object here, and if I just plant it here, you'll see it's attracted down to the sun because of the gravity of the sun. Doesn't matter which direction I put it in from, left, right, up, down. It's attracted to our center of gravity, or the largest mass, which happens to be the sun in this case. Now, if I drop these down and give it some motion, you can see that we can actually create an orbit. Now, it's pretty hard with this one to create a near circular orbit. Sometimes I can get it right, but this orbit is more like a comet. Now, let's turn on the paths so we can see the trace that leaves. And we'll let that take a few revolutions around our sun just to establish what our orbit looks like. And you can see that we've got a nice, steady, elliptical orbit tracing around the sun there. Okay, let's see if I can introduce another one. And there'll be a slight interaction there between this one and that one. You see that that one's actually throwing it out of its orbit a little bit. And that's just from the gravity of this little object here. It's already had an effect on this one here because they were passing by so very closely as they went around the back of the sun there. So now we've got these two orbits fairly steady here. Now I'm going to go and drop a brown dwarf, a huge object in the middle here, and I'll give it some motion as well, so hopefully it doesn't just plop into the sun because of its gravity. And let's see what happens when I release it. Okay, now you see it's actually also caused our sun to do a wobble, which is exactly as we should expect, and it's completely thrown the orbits of our comets out. Oh, and one has just plopped into the sun there, so there's one gone, and we've now got chaos in the middle of our solar system. And this is gravity at work, folks. So, you know, the claims that there are 5 brown dwarfs next to our sun, or 3 brown dwarfs, it doesn't matter even if there was just one. You can see the sort of chaos that it would be causing to our orbits, and we wouldn't be able to make predictions of solar and lunar eclipses and other events such as transits and occultations, because everything would be completely thrown out. So that's a fun little gravity simulator there, and as you can see, the orbits are a mess. So let me scroll up and see what else we've got there. I'll just stop presenting on that one. And let's look at the comments. Now, by the way, if anybody wants to take a look at the sun and to do it safely, one of the ways that you can do it is to go down to your local hardware store or engineering supplies store and buy a number 12 or darker if you can welding lens. Should only cost maybe $2 or $3. And if you can, ask if you can actually take the welding lens outside and try it first. Obviously you want to ask so they don't think that you're stealing it, because some of the welding lenses are more opaque than others. Some of them have a milky sort of transparency, and the best ones that you want provide a nice, sharp, clear transparency for best results. So you can use that to look through with your eyes if it's a number 12 or darker, preferably darker than 12 if you can, but you can certainly use it over the front of your video camera or cell phone or whatever to get some good pictures of the sun without all the glare. Of course, you should never look at the sun without using a suitable filter, as you may damage your eyes. I'm just scrolling up into the comments to see if there's any other comments I can reply to. A lot of the comments are in reply to other people in the chat, which is good to see. Some discussion going on there. Galboy 1967, hello Daz, I love your work. I can't get my head around how the Earth shadow moving across the moon is opposite to what I would expect to see during this, let me try and pronounce this right, selenelian. Now that's quite a mouthful. I gather you're talking about when there is a solar eclipse. Let me get my head around this. I've looked at this before. Sometimes it appears that you're looking at it'd be a lunar eclipse, where it would seem to be an impossible eclipse because of the alignment of the sun and the earth and the moon. This is one that I've actually intended to do a video about some time back, but like many of the videos that I often intend to do, I never got around to it. People need to remember too that you know, that the sun, it doesn't take much for the sun to be shining up underneath the earth and over the top of the earth, if you know what I mean, in relation to shining on the moon. And the shadow that that you're talking about there, Delboy 1967, yes, that sort of threw me too when I looked at it, and it's pretty hard to explain just in a hangout like this. I would actually have to do a video where I actually show what's going on, because when I looked at it, I was scratching my head as well and thought, how is this possible? And I did actually work it out using Starry Night. And as I say, I was looking at doing a video about it, but I never got around to it. When you look at that type of eclipse, it does seem impossible for the way that the shadow moves. But when you understand what's going on with people being, you know, upside down in relation to viewing, we're looking up in the sky. I guess part of it is also that if you look at a sky chart, you'll notice that east and west are always reversed, and that often throws people because they think maybe the chart has been printed wrong. But of course, it's not a chart of the ground, it's a chart of the sky, and it's designed to be held up over your head. That is why when you look at a sky chart, east and west are reversed, because it's intended to be held over your head. But that would be quite a good topic for a detailed video, and I definitely need the visual graphics to actually explain what's going on with that. It's much too complicated to try and explain just in a Hangout alone. Just looking at some of the other comments again. Okay, Flat Earth Math says, my understanding is that number 14 is one safe for extended sun viewing. Nice green color, but you can watch all day. Number 12 is better for cameras. Yes, I'd agree with that too. As I recall, sometimes it's quite difficult to get hold of anything darker than a number 12, but certainly if you can get hold of a number 14, that would be ideal for viewing directly through the filter. Or better still, you can actually order online the proper solar viewers for viewing eclipses and so on. Or you can also order the beta solar filter from various sources. You can either get it directly from the manufacturers in Germany. You can buy it in sheets and make up your own viewers, make up filters to go over your camera or over your telescope, and it provides a safe means for viewing. And again, even the beta solar filter actually comes in two different grades. One is intended for photography, the other is intended for direct viewing with your eyes. Okay, I'm just reading through some more of the comments there, so just bear with me. Now, I've been meaning to follow up about setting up another Equinox challenge, the Flat Earth Equinox challenge. Of course, we've got that next Equinox coming up in September, around about 21st, 22nd. I haven't checked the exact date for this year. But a couple of people have contacted me keen to see another Equinox challenge. And yeah, I'll try and set up another event on Facebook and put out some videos on YouTube to try and get people collaborating on that. Now, last time, even though we put the invitation out to everybody, flat earthers and globe earthers alike, there was not one contribution from a single flat earth believer. We had 9 different contributions from globe earth believers, but not a single video from a flat earth believer. So I'm hoping on the challenge again, there might at least be some contributions from the flat earth believers. Now what that's all about, of course, is to actually film the sunrise and or the sunset on the equinox when the sun is rising due east and setting due west. Now this should be impossible on flat earth. This does work, of course, the geometry is correct for a globe earth, but it should be impossible on a flat earth. So I'd like to see the flat earth believers filming their particular sunrise and sunset from their location and confirm whether it is in fact rising due east and setting due west, and explain to us all how that could possibly work on a flat earth. We can put all of the observations together and do an analysis and look at the geometry and see what conclusions we can come to. I'm Rick, Dazzathecameraman. During a daytime moon, it often appears the sun wouldn't be casting the shadow that we see from the Earth. Can you explain? During a daytime moon, it often appears the sun would, I don't quite follow that. Let me scroll back up, it's disappearing on me. Wouldn't be casting the shadow that we see from Earth. When you look at the moon when it's during its phase, the illuminated part of the moon is always facing the sun. I think there may be some optical variation in that. It's a bit of an illusion, depending where the moon, the sun, and the moon are in your sky. But I quite like the little photos that Caleb Hubble has been sharing on Facebook. I hope I'm pronouncing your surname correctly, Caleb. Caleb has been photographing the moon in the daytime sky along with, say, a golf ball, and showing how the illumination and shadow on the golf ball matches exactly what we see of the illumination of the moon in the daytime sky. And that is, of course, because the golf ball has also been illuminated by the sun. We see that the angle of illumination is exactly the same, just as it should be. Flat Earth Math says, Dazzathecameraman, I have a series of 6 experiments, explorations specifically for the equinox. 6 separate things to measure, observe on that day. Well, that would be good to have a look at, Flat Earth Math, and maybe we can incorporate those measurements in a collaboration with the Flat Earth believers as well. Now, I should point out, of course, is that I don't have all of the answers to everything. A lot of the things that I end up debunking, I have to go away and do some research on. And there are some things that even seem quite puzzling for a little while, and I have to scratch my head and say, what's going on here? So I have to go away and do some research. So I won't pretend that I know everything and that I have all of the answers all of the time, and that I can produce a correct answer always straight off the cuff. Sometimes I have to go away and do some research, as anyone should. Didn't the Flat Earth community do some measurements during the last equinox? Anyone know what the conclusion they came to? I don't know, Delboy, 1967. I'd be interesting to see. But I mean, clearly the geometry will not work. You can't have the sun rising due east and setting due west on a flat Earth as seen from every location. But of course, our flat Earth believers are very good at using phrases like perspective and vanishing point and so on to make the impossible seem possible, even though they are not actually correctly applying those terms that they're using, vanishing point and perspective and so forth. But they just throw that word out there and suddenly the impossible becomes possible. Yeah, that little experiment about holding up a ball will match the illumination of the moon. I've been meaning to do that as well, take some photos. I think that's quite a neat little experiment. I actually want to get a golf ball though, because you know the golf ball's got little dimples in it. So I think the shadows will provide a more effective sort of view of what we're looking at. I seem to remember seeing some giant golf balls in the local $2 shop one time, so I think that would be ideal for doing that sort of thing. The Moon Terminator illusion, that's the one. It says Flat Earth Math. He's replying to I'm Rick in the chat. It's called the Moon Terminator illusion. If you picture the sky as a hemisphere and trace a line on the inside of the hemisphere from the sun to the moon, it will nail it perfectly. Yeah, that's right. Lunar wave. Yeah, we haven't talked about the lunar wave for a while. A couple of years back, I did a series of videos debunking Crow 777 and his lunar waves. Well, I couldn't prove conclusively that the actual cause of the lunar wave, except to say that I was 100% sure that it was an atmospheric phenomena, which could be caused by passing aircraft, and I provided some very specific examples of that happening. And it was quite good because Astronomy Live was actually filming the moon one night during this time, and he noticed something strange happening with the moon as he's looking through his telescope, and he looked up and there was an airplane flying right past the moon. Now, it didn't actually cross over his field of view, as I recall, but the wake aircraft caused as it flew past the moon actually caused a lunar wave which swept across the moon. Now, it wasn't a perfectly clear lunar wave as we saw in some of Crow's videos, but it did actually show the distortion that was caused by that wake. And I do believe that what we're actually seeing in Crow 777's videos, it's less likely that it's a passing aircraft. I think it's more likely the boundary between passing warm and cold air masses. So you've got a difference in the refractive index between the air masses because of the different temperature. And I mean, even myself, when I've been filming the moon rising, you get this layering effect. And I believe that's exactly the same sort of thing that we're seeing in Crow 777's lunar wave videos. He claimed, of course, that it was some sort of glitch in the moon hologram, which of course is ridiculous unless you're really, you know, subscribe to that paranoid sci-fi fantasy sort of nonsense. A glitch in the moon hologram, and that they were trying to hide the real moon from us so that we couldn't really see what was going on the moon. Occam's razor, of course, that the most likely explanation is that it's atmospheric, and we're able to demonstrate that by using aircraft flying by the moon, causing the wake from their engines and also their wingtip vortices actually causing a wave as the air swept across in front of the moon. So it's good to see some discussion backwards and forwards in the chat there. And as I said at the start of this Hangout, normally I'm very focused during the Hangouts because of the topics that we're covering. And unfortunately, the chat doesn't get the attention it probably deserves. So it's quite nice to be able to do a little impromptu Hangout and try to respond to some of the comments in the chat. Just going to have a glass of water before I lose my voice. So, is the moon flat? Well, that's another thing I've looked at, John Darwin. Is the moon flat? I've looked at that question in some of my earlier flat Earth videos. If you go to my channel, click on my playlists and search for flat Earth, or just scroll through the various playlists there, you'll find some of my videos debunking the flat moon. Now, if the moon was flat, then depending on our angle that we're viewing the moon, of course, it would then appear to be oval. Because if you look up at your ceiling, if you've got a round circular light fitting on your ceiling, and you look up at it from directly below, then you will see that that fitting appears to be perfectly circular. But if you're across the room and you're looking up at your ceiling at, say, a 45-degree angle, you see that your circular light fitting appears to be oval from that angle. And the same would apply to the moon. I mean, aside from the fact that we can see the angle of the shadow in the craters, as the moon orbits the Earth. The angle into the angle of the shadow into the craters is constantly changing. We can see clearly through a telescope that it is a sphere and not flat. I mean, anybody that's ever looked through a telescope looking at the different phases of the moon, of course the worst time to look at the moon is when it's a full moon, because all you see basically is a big white disk, and it does look rather flat. But if you're looking at the phases throughout the month, then you'll see that it is very clearly a sphere and not flat. Just looking at some of the other comments again. Maybe we should get I'm Rick in for a hangout sometime, a group hangout to discuss some flat earth claims, flat earth math. Maybe you would like to join for a hangout with I'm Rick, and we can discuss some of those flat earth claims. How would you guys feel about that? I'm Rick and flat earth math, a group hangout. You up for that? And John Michelson says, no flat earther will ever address how their moon can be hovering 3,000 miles up, yet everyone sees the same craters and same phase at the same time all over the world. And that's exactly right. You know, it doesn't matter whether I'm viewing the moon from New Zealand and somebody else is viewing the moon from the United States, which is possible, by the way. We're looking at the same side of the moon. Now, one side of the moon always faces the Earth, which is why we always see the same side. We can actually see slightly more than 50%. I think we can see about 60% of the moon in total, because of what's it called? Libration is the term. There's our view of the moon. If we're looking at the moon, I might actually try and pull up a video too, just to show that. Our view of the moon does a little rock, and through that rocking or libration, we can actually see up to 60% of the moon. So let me see if I can pull that up. Now, I see that Flat Earth Math has replied to the question, and he said, yes, I'd love to join with I'm Rick. I'll argue I'll argue for the flat earth side. Okay, I'm Rick. I'm not a flat earther, I'm just a jokester. Okay, all right, fair enough. Sometimes it's fun to play devil's advocate and argue for something just for the fun of it. Anybody that did debating at high school, you might remember that you had to take on a topic that you might not even agree with, just to see if you could put forward a good defense of that topic. I remember being at a job interview several years ago, and that was one of the tasks that they gave us to do. And it was interesting how the discussion got quite heated at times, even though none of us probably really actually believed in what we were arguing for. It was quite interesting. All flat earthers are jokers. Yeah, I think a lot of them are actually, but unfortunately they also do influence people who believe it's all serious. I've got no doubt that there are a lot of trolls out there who are just joking around and are fooling a lot of people. But unfortunately, just like the whole Nibiru hoax, they do tend to fool a lot of people, and a lot of people get sucked in and they really believe it. Now, okay, I'm just pulling up a video for moon libration so we can look at that. And there we go, from LRO. NASA Goddard. Okay, so I'll share my screen with you. Hopefully you'll be able to see this. I know that in the Hangouts, you might be able to change your video settings so that it's nice and clear. Otherwise it might be a bit fuzzy, but you'll get the idea, I think. So here we go. Here is libration of the moon. So you can see that the moon appears to do this sort of wobble, and sometimes it's close to us, sometimes it's further away. And because of this sort of wobble that it does, we can actually see not just 50%, as you would expect if we could only see one side of the moon ever. We can see up to 60% of the total surface of the moon, and that is called libration. So just as you see the moon getting further away there, and now it's coming back towards us again, that's called apogee and perigee. The closest and furthest points away from the Earth. Now, just to put things in perspective, when we look at the moon, it sort of looks like it's not really very far away, but in fact, it's on average it's 30 Earth diameters away from the Earth. Difference in its distance is 2 Earth diameters. In fact, if you look out here to the right, you can actually see the moon's position. So there is the Earth out there, and there is the moon's position. So on average, it's 30 Earth diameters away. When it's at its closest point, it's 28 Earth diameters away. When it's at its furthest point, it's about 32 Earth diameters away. So I'll just run that again, and you'll see this distance slowly going backwards and forwards there. I'll just get rid of that. There we go. So you can see that distance changing. And of course, sometimes we have the supermoon events where the moon is particularly close to the Earth and looks about 14% larger in the sky than it normally does when it's at its average distance of 30 Earth diameters away. So that's libration and how that works. Okay, let me just catch up on the chat again. So just let me know in the chat too. I'll wind this up soon because we're approaching an hour, and I never like my Hangouts to go too long because I know that people don't like to watch them if they're too long. But let me know how you feel about these sort of impromptu Hangouts where we interact more with the chat. Would you like to see more of these Hangouts? It's certainly very easy for me to set up a Hangout like this. Unlike doing a debunking video, it often takes a lot less effort and mental energy, which often I don't have. But I'm quite happy to do a Hangout. We can just sit here and chat and pull a few things up and answer a few questions, and it's a lot of fun. So let me know if you'd like to see some more Hangouts like this, and I'd be pleased to do some more if you would like that. Well, Geo Streber, who just started watching, the Hangout will be up on the channel, so you can watch it again from the start if you want to later. So no problem there. Good to see that there's been some discussion between Flat Earth Math and I'm Rick about the whole Flat Earth thing. In playing devil's advocate, I think. Now, I've been hoping to get back down to Makatu, which is southwards down the east coast from where I live. This is where I filmed Mount Maunganui from a couple of months back, and I was able to show that I couldn't see the shoreline or the buildings from the shoreline at Makatu, but when I went 200 feet up the hill behind Makatu, I could actually see the waves breaking on the beach at Mount Maunganui. And I've been hoping to get back there under ideal weather conditions where we didn't have any mirage effect causing that sort of mirroring effect, which can obscure things, and people say, oh, well, you know, that's hiding the shoreline and all the rest of it. So I'm hoping to get down there sometime when we've got nice clear weather, which we certainly don't have right now. Also, we're in winter now, so the weather's not so hot. We won't be getting so much haze, but I just have to wait for fine weather where it's not raining or hazy or cloudy or foggy, and it should have a nice clear view of Mount Maunganui from Makatu, which is over a distance of 18 miles, by the way. It always amuses me when people send me these links on YouTube or Facebook and they claim to show some distant city or some distant location over a distance of 75 miles, and they claim that, well, they claim first of all that that's the distance, say 75 miles or 60 miles or whatever they claim it is. They don't provide the details of where the photos were taken from, the elevation, the exact location, so it can be verified. But it just seems really odd to me that they claim to show these buildings and things and different features from these incredibly long distances away, yet I can go down to Makatu and film Mount Maunganui from 18 miles away and I can't see the shoreline or the buildings or the bottom of Mount Maunganui, which is about 760 feet high. So there seems to be a contradiction there. But then, of course, they'll just trot out those magic flat Earth words such as perspective and vanishing point and all the other magic flat Earth words that they use to explain away what they can't explain and make the impossible suddenly possible. So apparently that's how it works. Okay, I'm going to wind this up in a few minutes. As I say, we're just coming up to the hour, and it's been good having you join me. We've got 31 people in the Hangout at the moment joining the chat, so that's good to see. And next time I'll try and give a bit more warning. And also the time for the Hangout, of course, doesn't always suit everyone because of different time zones. Right now it's 6:15 p.m. on Friday evening here in New Zealand, and for some people that's probably very early in the morning elsewhere around the world. So thank you for joining me. Thank you for your participation in the chat, and thank you always for your support. And with that, I'll close the Hangout, and we'll see you again next time. Thank you.